Hello everyone. In this lecture I shall discuss the solution of first order and first degree differential equations. If you think of the implicit form of the differential equations, it may be like this. It involves y dash only because of the first order. Also we consider the degree 1 also, and it involves x, y and y dash implicitly of this form, or it may be of this form, or it may be of this form. Okay, so now there is basically no specific rule exists to solve it. Okay, however there are some routine methods available to solve these. Methods are as follows: variable separation method, homogeneous differential equation, exact differential equation, method of integrating factor. Actually this integrating factor means reduce to exact form. Okay, means we use this method to reduce it to exact form. Then linear differential equation. Then coming to the Bernoulli differential equation, means Bernoulli will reduce to the linear. Okay, Bernoulli differential equation means we reduce it to linear form. Likewise the integrating factor is used to bring it to the exact form. Okay, so before the detailed discussion of the individual methods, let me to introduce myself. Myself Professor Susanta Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Odisha, India. So now without much delay, let us now discuss the first two cases in this lecture, method of variable separation and homogeneous differential equations. So now coming to the variable separation method. In variable separation method, so we are given mxy dx plus nxy dy is equal to 0. We simplify it in such a way that we will bring x term in one side and y term in other side. Say phi x dx is equal to psi y. Okay, now we integrate it. Okay, we integrate it here. Phi x dx is equal to psi y dy plus c. After integration, c is the arbitrary constant. Okay, arbitrary constant, and now this will be my solution. So let us use this technique to solve some examples. So now let us solve these two examples. One is dy by dx is root over of 1 minus y square by 1 minus x square. Then second one is y plus 1 dx minus x plus 1 dy is equal to 0. Now coming to the solution of 1. So now dy by dx is equal to 1 minus y square by 1 minus x square root over. Now the question is this plus this is equal to 0. This is the question. Okay, so we have dy by dx is equal to minus of root over of this. So this implies you collect the y term in one side. Dy by root over of 1 minus y square is equal to minus dx by root over of 1 minus x square. Okay, now variable separated, integrate both sides. Okay, now you integrate both sides. So that means in the left hand side it is sine inverse y, in the right hand side it is minus of sine inverse x. Now you have a constant of integration, so we write the constant of integration as sine inverse. Instead of c we just write it sine inverse c to get a pattern. Now we bring it to this side, so that means sine inverse y plus sine inverse x is equal to sine inverse c1. Okay, if we write only c also no issue, we write now to get a pattern, and if we leave it here also then it's fine. Now if we want to simplify it, then it is like this. We apply here sine inverse x plus sine inverse y formula. So it is sine inverse of x into root over of 1 minus y square plus y into root over of 1 minus x square is sine inverse c. Okay, sine inverse. So if I write only c1 then fine also, it is sine inverse c. So now it is simplified. It is x into root over of 1 minus y square plus y into root over of 1 minus x square is equal to c. So this is my answer. Okay, if I leave it here, okay, if I leave it also here, then also okay, right, then also okay. Now coming to the solution of 2. In question number 2 you have y plus 1 dx is equal to x plus 1 dy. Okay, now we separate the variables. Now we bring it to this side, bring it to this side. So this implies dx by x plus 1 is dy by y plus 1. If you integrate both sides, in the left hand side it is ln x plus 1, in the right hand side it is ln y plus 1. Now to get a pattern I write ln c. If instead of this I write some c1, then also fine. To get a pattern and to get a better answer I write it ln c. Now if I simplify it, bringing this to this side, ln x plus 1, ln a by ln b, right, ln x plus 1, ln a minus ln b, it becomes here y plus 1 here is here ln c. Okay, so now ln taking exponential to both sides, it is x plus 1 by y plus 1 is here c only, it is here c only. So that means here x plus 1 is equal to c into y plus 1. So this is your answer. Okay, now coming to two more examples, example 1 and example 2 under B. So here some sorts of substitution is needed. After that we will separate the variable. We need some substitution here. Okay, so coming to the solution 1, dy by dx is equal to root over of x plus y. Put x plus y is equal to t square. Okay, so that means if you differentiate both sides, 1 plus dy by dx is 2t dt by dx. You substitute it over here. So this implies your 1 plus dy by the, so your dy by dx bring 1 to this side, it is 2t dt by dx minus 1. In right hand side it will be root over of t square is your t. Now you separate the variables t and x. So that means your 2t dt by dx is equal to your 1 plus t. Okay, now you separate it. 2t by 1 plus t dt is equal to your dx. Now little bit adjustment is needed. In denominator it is 1 plus t. So in the numerator I want to write it 2 into 1 plus t. So to make it balance here, I subtract 2 here. In the denominator it is 1 plus t dt. In the right hand side it is here dx. We are integrating both sides. Okay, so now, so if you simplify it, or we may later on we may integrate it. So now here if we separate it, it is twice integral dt minus twice integral dt by 1 plus t is here integral dx. So now on integrating here, it is twice t minus twice ln 1 plus t is equal to your x plus c. Okay, so just you simplify it, just substitute the value of t. T will be here root over of x plus y, t will be root over of x plus y, 2 into root over of x plus y minus 2 ln 1 plus root over of x plus y is equal to your x plus c. We leave it here, or we may write here on integrating. Actually we skipped one step here, so we write it. Next, coming to your solution 2 under B. Solution 2, it is xy dash plus y is equal to xy dash is equal to y plus 3x fourth cos square y by x. You see here there is a y by x. Okay, so you bring this x to this side. If you divide it, y dash is equal to y by x plus 3x cube cos square y by x. Now we may substitute your y by x is equal to t. Okay, or y by x is equal to b. Now we put y by x is equal to v. So this implies y is equal to vx. If you differentiate it, your dy by dx is equal to v into 1 plus x dv by dx. So in place of y dash, you substitute this. So this implies v plus x dv by dx. Here in the right hand side, it is v plus 3x square cos square v. Now we separate v and v cancelled in both sides. Okay, so this implies your x dv by dx is 3x square cos square v. Now this x and x square cancelled here, bringing cos square to this side, it is my sec square v. sec square v dv. In the right hand side it is 3x dx. Actually it is xq here, it is xq. Okay, so it is xq, so it becomes here x square. Now you integrate both sides. Okay, this implies sec square v dv integrated is 3 integrated x square dx. So after integration, sec square v is here 10v is equal to 3 here xq by 3 plus here c. Now this 3 and 3 cancel. Now you substitute the value of v. So v is here y by x. It is tan y by x is equal to x cube plus c. So this is your answer. You leave it now. Now let us solve two more examples under the initial value problem. Now let us solve two more examples. These are the initial value problem. Initial condition is given here. Okay. So now coming to the solution of one. L di by dt is equal to minus of Ri. Okay, I bring it to right hand side. So now we separate it. So that means di by I, bring I to this side. Okay, is equal to minus R by, you bring L and dt to that side, R by L dt. Okay, now on integrating, so that means di by I is minus R by L dt. Now on integrating, we have R by L is a constant. Here ln I is equal to, so it is minus R by L t, and here constant, suppose I write a constant, is ln C. Okay, so to get a better answer, instead of ln C, if I write simply k is also okay then. Okay, but I take it. So now bringing this to this side, so this implies ln I by C, okay, is minus R by L t. So that means removing ln, it is I by C is e to the power minus of R by L t. Now you impose the conditions. So this implies here I is equal to C into e to the power minus R by L t. Now impose the condition. Now the condition is next, I of 0 is equal to I0. What does it mean? It means when t is 0. Okay, implies here I is equal to I0. So substitute this. So that means I0 is equal to C. This is e to the power 0. E to the power 0. So that means here C is equal to here I0. Now you substitute the value of C here. Okay. So that means here I is equal to I0 e to the power minus of R by L t. So this is my answer. Okay, this is my answer. Next, coming to the last problem here. In example 2, actually the condition is y of 0 is equal to e. Okay, now coming to the solution here. So y of 0 is equal to e here. Okay, so now on solving, so this implies here dy by dx is e to the power x into y. So this implies here dy by y is e to the power x dx. You integrate both sides. So this implies here ln y is e to the power x plus ln c. Let us simplify. Now you impose the condition here. Y of 0 is equal to e. So what does it mean? When x 0 implies y is e. Okay, so you substitute it here. So that means ln e is equal to e to the power 0 plus ln c. So ln e is 1 is equal to here 1 plus ln c. 1 and 1 cancelled. So that means here ln c is equal to 0. For what value of c it is 0? So c is equal to here 1. So you substitute the value of c as 1 here. So substituting this here, so this implies ln y is equal to e to the power x plus ln 1. Ln 1 is 0 here. So that means here ln y is equal to e to the power x is your answer. So this is all about the variable separation. Next we discuss the homogeneous method. Next, coming to the homogeneous differential equation. Now the idea is the homogeneous differential equation with proper substitution we will bring into a variable separate form. Phi v dv is psi x dx. Okay, so this is the idea actually. So now this homogeneous is reduced to variable separation, right? So what is a homogeneous equation? You see, if I write this is a function here, now the degree is 2 here, the degree is 1 plus 1, 2 here, the degree is 2 here. So it is homogeneous of degree 2. Right now here it is 3, but here it is 2 plus 2 is 4 here. Here it is 2. You see, all are not having the equal degree. So this is non-homogeneous. Non-homogeneous, right? This is non-homogeneous. So a differential equation is said to be homogeneous if it is like this. So now coming to the homogeneous differential equation, a differential equation of the form mxy dy by dx is equal to mxy by nxy. Okay, this is the standard form. A differential equation of the form this is said to be homogeneous. Said to be homogeneous if, okay, this is a homogeneous function, this is a homogeneous function, and both are having the same degree. If both mxy and nxy are homogeneous function, one thing is homogeneous function and of or with same degree, right? With same degree. So you see two conditions here. Both are homogeneous, it need to be homogeneous, Again, the degree of both this m and n are same. These two conditions need to be checked. Okay, here you see the degree is 2, the degree is 2, the degree is 2 here. So the homogeneous of degree 2 here. Similarly, both this is homogeneous and this is homogeneous, and they must have the same degree. Okay, so now let me write some example. If I write, suppose dy by dx is equal to x plus y by x minus y, right? If suppose write dy by dx is equal to x square plus y square by xy. If I write dy by dx is equal to x square plus y square by 2x xqy plus 5yq. You see here, so this is homogeneous of degree 1 here. In the denominator it is homogeneous of degree 1. So yes, it is homogeneous. So here the degree 2 and 2. So this is homogeneous of degree 2 and this is homogeneous of degree 2. So yes, it is homogeneous. But you see here in this case, right, this is homogeneous of degree 2 here, and this is also homogeneous. This is 3, say x square y. So now this is 3 and this is 3, but this is homogeneous of degree 3, right? It is homogeneous of degree 2. Finally this is not homogeneous differential equation, right? So now what is the working rule? So now coming to the working rule, consider dy by dx is equal to mxy by nxy be homogeneous. Now step 1, put y by x is equal to v. So that means y is equal to vx. Differentiate both sides. So dy by dx is equal to product formula v plus x dv by dx. Okay, now you substitute this over here. So in second step, so let it be your equation 1. Now you substitute this value of y and this in equation 1. Okay, and separate the variable. Means there will be no y variable as v in one side and x in another side. Okay, now integrate it and integrate. Okay, in the final step 3, what you have to do? Originally in place of v you substitute y by x. Put y is equal to v by x. Put v is equal to y by x, and the solution is of the form fxy is equal to 0. Okay, So this is the idea. So let us solve one example. Now given one example, so you see this is M and this is N. It seems homogeneous of degree 2. It is homogeneous of degree 2 here. So let us rewrite it. So that means your 2xy dy is y square minus x square dx. Okay, so that means your 2xy dy by dx is y square minus x square by 2xy. Now you see here the numerator is homogeneous of degree 2, the denominator is homogeneous of degree 2, so it is homogeneous, right? You put y is equal to vx, so that means dy by dx is equal to v plus x dv by dx. Now you substitute here, so that means v plus x dv by dx is y square is v square x square minus x square by 2x into vx. Okay, so in the numerator you take common x square, it is v square minus 1 by 2vx square. Now x square and x square is cancelled here. So this implies here x dv by dx, bring this v to this side, is v square minus 1 by 2v minus your v. You simplified v square minus 1 minus 2v square divided by 2v. So this is equal to minus of v square plus 1 by 2v. Now you separate the variable here. Okay, bring v to one side and x to another side. So it is 2v by v square plus 1, bring to this side, and it is minus of dx by x. Now you integrate both sides. You see this 2v is nothing but the derivative of the denominator. So that means d of v square plus 1 by 2v is minus of dx by x. Okay, so on integration in the left hand side you have this is v square plus 1. So v square plus 1. In the left hand side d of this by this is ln v square plus 1. In the right hand side it is your minus ln x. We write the constant as ln c. So in the right hand side it is ln c by x. So now this implies here v square plus 1 is equal to your c by x. Now the value of v you substitute here. V is your y by x. So that means y square by x square plus 1 is equal to your c by x. So if you simplify it, your x square plus y square is equal to your cx. So this is your answer. Okay. Next, coming to equation reducible to homogeneous form. Right. The equation is not directly homogeneous, but we can reduce it. Suppose there are two cases. Type 1. In type 1, your dy by dx is equal to a1x plus b1y plus c1, and by a2x plus b2y plus c2. And here the case is a1 by a2 is not equal to b1 by b2. Right. If this is so, then what is the methodology? You put x is equal to x plus h and y is equal to y capital Y plus k. So h and k are constant. So this is small dx is capital dx and small dy is your d capital Y. So therefore your small dy by dx is capital dy by dx. Okay. So now you substitute that over here. So that means your capital dy by dx will be equal to your a1 into capital X plus h, this value of x, plus b1 into capital Y plus k, plus your c1 divided by a2 capital X plus h plus b2 capital Y plus k plus c2. So you separate this term. So this is equal to a1x plus b1y capital Y. Okay, and plus the remaining terms here a1h plus b1k plus c1. You separate it like this. Accordingly, in the denominator here a2 capital X plus b2 capital Y, and the remaining term you collect hk and c2 plus a2h plus b2k plus c2. Now you choose h and k such that this and this are 0. Right. Choose h and k. Choose h and k such that here a1 h plus b1k plus c1 is equal to 0, and here a2h plus b2k plus c2 is equal to 0. If you simplify these two, you can easily get the value of h and the value of k. So with this value of h and k, this and this are 0 now. So now this will reduce to, here capital dy by dx. Capital dy by dx is a1x plus b1y divided by a2x plus b2y. Now you see, this is homogeneous of degree 1, this is homogeneous of degree 1, so therefore it is here homogeneous. Okay, so thereafter, since this is homogeneous, you put capital Y is equal to small v into capital X, and you repeat the process here. So that means here dy by dx is equal to v plus capital X dv by dx. Okay, now you continue the process and separate the variables. Now next you continue the process to get the solution of the form fxy is equal to 0. Okay, so this will be our final answer. So now let us solve one example. Now consider this example. Now coming to the solution. So here this is a1 by a2 is here 1 by 2. Okay, and what is here b1 by b2? Here it is 1. b1 by b2 is 2 by 1. So a1 by a2 is not equal to b1 by b2. So you put small x is capital X plus h and small y is capital Y plus k. So therefore here small dy by dx is equal to capital dy by dx. With this, now one follows, here dy by dx is equal to x plus h plus 2y plus 2k minus 3 divided by 2x plus 2h plus y plus k minus 3. You now write it here, x plus 2y plus h plus 2k minus 3 divided by here 2x plus y plus 2h plus k minus 3. You choose h and k such that this and this are 0. Okay, let it be equation 2. Choose h and k such that h plus 2k minus 3 is equal to 0 and 2h plus k minus 3 is equal to 0. You have to solve these two. Now if you adopt the cross multiplication, then here h divided by this into this minus this into this, h divided by minus 6, then minus plus 3, and the middle one is minus k divided by. Now for middle one it is this into this minus this into this. Okay, so it is minus 3 plus 6, and for the final one, it is 1 by, now this into this minus this into this. So it is 1 into 1 minus 4. If you simplify it, okay, this and this with this, and you solve it. Solving, h is equal to 1 and k is equal to 1. So with h and k, now equation 2 follows. Dy by dx is equal to x plus 2y divided by 2x plus y. Now this is homogeneous. So you put capital Y is equal to v into capital X. Okay, so as usual process. So dy by dx is v plus x dv by dx. So this implies my v plus x dv by dx is equal to x plus 2 into vx by 2 into x plus vx. So taking x common, it is 1 plus 2b by x taken common, it is 2 plus v. So now here x and x cancelled. So that means here x dv by dx is equal to 1 plus 2b by 2 plus v minus v, bring v to this side. So this is equal to 1 plus 2v minus 2v minus v square by 2 plus v. So now this 2v to be cancelled, it is equal to 1 minus v square by 2 plus v. Now you bring this to right hand side and bring this to left hand side. So that means my 2 plus v by 1 minus v square is here dx by x. So now integrate it. In the left hand side it is 2 plus v by 1 minus v into 1 plus v. Right hand side it is dx by x. Now here you apply the partial fraction here. Partial fraction. So now in the left hand side it is a by 1 minus v plus b by 1 plus v is equal to your dx by x. Now you solve the value of v. Okay, you see, put v is equal to 1 here, you put v is equal to 1 here, okay, and you close it. It will be this by this, it will 3 by 2. So the value of a will be here 3 by 2 here. Okay, so it will give you b is equal to your half. So if you simplify it, so now if you simplify it, 3 by 2 here, this is dv, this is dv, dv by 1 minus v plus half dv by 1 plus v is equal to your dx by x. So now you simplify. So this is because of your partial fraction, partial fraction. Okay, now if you simplify, it is 3 by 2 ln 1 minus v plus half ln 1 plus v is your ln x plus ln c1 say. Actually one minus sign will be there, one minus sign will be there. So simplify. So multiply 2 and simplify. It is your ln 1 plus v minus 3 ln 1 minus v. 2 is multiplied. It is 2 ln a plus ln b ln ab 2 ln c1 x. So this implies ln a by ln b. So it is ln 1 plus v by 1 minus b whole cube. This will become to this power here. So this will be ln c1 x whole square. Cancelled ln both sides. So that means 1 plus v by 1 minus v is equal to c1 square x. c1 square x square. Now we may write this c1 square is equal to here c x square. c1 square is equal to c say. Okay, c say. So now we put the value of v. V is here capital Y by capital X. So you substitute that. So 1 plus y by x is 1 minus capital Y by x is cx square. So now you simplify it. It is x plus y by x minus y is equal to 1 whole q is there, 1 whole q is there. Okay, 1 whole q is there. So if you simplify it, this whole q will be equal to your c. So this implies your x plus y is c into x minus y whole q. Now what is your capital X? It is small x minus h. Capital Y is small y minus k. H is equal to k is equal to 1. Let you substitute it. So that means your x minus 1 plus y minus 1 is c into, it is your x minus 1 minus of y minus 1 and this is whole cube. Okay, so if you simplify it, it is x plus y minus 2 is equal to c into x minus y whole cube. So this is our answer. Now in type 2, it is dy by dx is equal to a1x plus b1y plus c1 by a2x plus b2y plus c2 with a1 by a2, a1 by a2 is equal to b1 by b2. So what will happen? Either this will be a multiple of this. Okay, so now because of this we have here a1 by a2 is equal to b1 by b2. Let you say it is here 1 by c. So that means what is here a2? a2 will be ca1 and b2 will be cb1. So you substitute this thing here. So this will be equal to your dy by dx is equal to a1x plus b1y plus c1. In the denominator it will be c times this. Okay, it will c times a1x plus b1y plus c2. Now if you put this as a some variable z say, then we will get it in variable separate form. So next you put your a1x plus b1y is equal to z and solve to get variable separation form. So let us solve an example, then your idea will clear. Now suppose this is the example you are solved. So this is my a1 and this is my a2. So a1 by a2 is equal to minus 4 by 2, and here b1 by b2, this is my b1. So b1 is here minus 2 by 1. Okay, so this is here minus 2 and this is here minus 2. So therefore this is equal to this here. Okay, so now you see, so this implies here dy by dx is equal to 1 minus 2y minus 4x. So I can take 2 common. Now if you take minus 2 common here, it is here y plus 2x, and in the denominator it is 1 plus y plus 2x. You see now this and this are same thing, or it may be a multiple of that. So you put now y plus 2x is equal to some z. Okay, so if you differentiate it, dy by dx plus 2 is equal to dz by dx. So that means here dy by dx is equal to dz by dx minus 2. So let it be my equation 1. Now 1 follows. Here dz by dx minus 2 is equal to 1 minus 2z by 1 plus z. Okay, now you simplify it. dz by dx is equal to 1 minus 2z by 1 plus z plus here 2. So if you simplify it, it is 1 minus 2z plus 2 plus 2z by 1 plus z. So now 2z cancel, it is 3 by 1 plus z. Now you separate the variable. Okay, bring this to left hand side, 1 plus z dz, and you bring this to right hand side. So this is equal to your 3 dx. You integrate both sides. So now you integrate both sides. So if you integrate both sides, you will get z plus z square by 2 is equal to 3x plus some constant c1. Okay, now the value of z is y plus 2x. You substitute that. So that means here y plus 2x plus y plus 2x whole square divided by 2 is equal to 3x plus here c1. So you simplify it now. Now you simplify, also bring this to this side. It is 2 into y minus x plus y plus 2x whole square. Bringing 2 to this side, it will be 2c1, or this 2c1 is equal to, I can say that this is my c. 2c1 is equal to c, say. Okay, so this implies it is my 2y minus 2x plus y plus 2x whole square is equal to c. This is my answer. Now coming to the summary of this discussion, we are given a first order and first degree differential equation of the form mxy dx plus nxy dy equal to 0. We first try to separate the variables. If it's directly variables are separated, then it's fine. If not, then we try to have some substitution and try to separate the variables. If it's separated, then it's okay then. If not, you see in certain cases it is a homogeneous differential equation, then with substitution of y is equal to v by x, we can again bring back to the variable separation form. Okay, in that way we should solve the examples, and you are advised to solve some more problems from the book. Any standard book you may solve it. Now in our upcoming lecture, we shall discuss the exact differential equation followed by your integrating factor and linear differential equations. Now at this stage, I appeal to all of you that if this lecture is interesting and useful to you, please like and subscribe to this channel. Okay, so it will boost my motivation to upload subsequent videos for your benefit. Thank you all.